Guys, I got here a Sony STR-DH130. Problem with this one is that when you power it on, yeah, it will turn on, the relay clicks, and then it goes to protection mode. Probably it could be an amplifier issue. Okay, so let's open it up. Let's do some visual checks in here. No sign of burns. Let's check this amplifiers here or the transistors. Let's check it with voltage first. It has 50 volts in here. We have to discharge it first. Okay, so let's check the transistors now. Let's see if there are some shorts. That's okay. Yeah, I think the main amplifiers are doing good. Good thing with this design is that you can see lots of resistors here. Easy to check if they're still good. And these resistors are low values, so mostly if the circuit has problem or short problems, it will blow out. So let's check these guys here. So it's 1 ohm, 10 ohm. It's 10 yellow violet, so it must be 4 7, and I think these guys are open. 2.3 big. And this one here, it's, yeah, it's in the mega ohms, 2.2 mega ohms. And this one here, yeah, so I think there's a problem with a power circuit. So we'll check this circuit here. Let's open it up. See if there are any signs of burn and signs of job being done in here before. So it seems quite clean. They have some regulators here. Swap is mounted. This one here. And I don't know about these guys here. These are +7 and -7 regulators. We must check this circuit here. It's the one that has bad readings. These two. Okay, I don't know where's this leading. So it's from a supply. Yeah, it's from a plus. Comes from here. What is this? What is this part in here? So it's sticky. So I think it's a preamp, eh? Sticky 3603333. This resistors here, it goes to here. So this is the open here. It's kind of open here. Yeah, it's the resistor here. It could be that it's the main problem here. Let's remove these two here. Ah. 4 7. And if it's silver, let's check if they're open. They have the same color bands. Reading 1.660 ohms. And the other one is reading around 27 kilo ohms. Okay, so these two are bad now. So if it's silver, it's gonna be times 0.01. 47 times 0.01. So 0.47. It must be 0.47, guys. I was looking for a resistor to use it temporarily. Found some resistors here with silver third band. Must read there 0.47. Yeah, it's red orange silver 0.23. 0.23. You can't read it from this, guys. See how does it read? Yeah, it just say 0.4. So when it comes to reading very critical values, it's better high resolution. So you can use it with this setting here, the low ohms. Well, you can use the normal ohm setting here. Yeah, it is 0.28. Yeah, our tester will read like around 0.08. Yeah, it reads 0.28 ohms there. 2.29. How about relative? Okay, so let's set that for relative. Okay, so relative means you're deducting the 0.5 resistance of your test lead. So yeah, we have here, yeah, there 0.23 there. You can also do that from here, relative, because the test leads are really, like example, the coating are torn up. You can use these resistors here. 0.2, yeah, 0.23, 0.23, yeah, 0.23, yeah. Okay, Okay. And then because the resistor that we just took out from here was 0.47. Okay, so we just series these ones here. Let's series these resistors here. We now have here 0.4 something. Yep. Yeah, 0.47. And this one here. Yeah. Oh, good. Man. Just make sure they don't short, man. There. Twink. As I look at the schematic, so the resistors that we just replaced here, these are the resistors that are feeding power or voltage to this IC here. So it could be that this IC has problem. That's why the resistors change its values. So this could be the problem here, but we need to confirm it. So the resistors that I just replaced are these ones here, and as you can see, it's going to this IC here. Yeah. And it is tapped to the voltage going to the main transistors also. So it's getting its voltage from the VCC and minus VCC. Okay, let's try this.